Hi there, so today we're looking at 7.3 surface area and volume of prisms. Our objective today then to be able to calculate the surface area and the volume of different three-dimensional shapes. Prior knowledge then, you should know and be able to use the formulae for the area of a rectangle, triangle, parallelogram and trapezium. So a quick reminder, the area of a rectangle is found by doing the length times the width. The area of a triangle by doing half the base times the height. A parallelogram is the base times the perpendicular height. And a trapezium is a half of A plus B, where A and B are the two parallel sides added together, multiplied by the perpendicular height. Make sure you're happy with those before you move on. If not, go back and have a look at those previous lessons first. Things you'll need for this lesson then, you need your maths book or some paper to write on, a pen or a pencil to write with, and your calculator. Alright, so let's start then with surface area of a cuboid. So cuboids and cubes, remember, are of the same family. So to be able to find the surface area is the area of all the different faces added together. So you need to think of it as an empty box and how much cardboard we need to be able to make that empty box. Okay, now with a rectangle has some properties that are helpful to us. So the opposite sides of the rectangle have the same area. So the front one here, which I've called A, and the back one, which we can't see at the back, have the same area. The top, which I've called B, and the bottom will have the same area. And the right side here, which we've called C, and the left side will also have the same area. So as long as I find the area of one of each, I know that I need two of that same one for the ones that I can't see behind. Okay, so altogether there are 6 areas that I need to add together to find the surface area of a cuboid. And it's really important to note down before you start how many different faces the shape has, because that's going to tell you how many areas you should be adding together at the end. Okay, so let's start off then by finding the area of side A. It's a rectangle, so we use our length times our width. So 8 times 5, which is 40 centimetres squared. Remembering its area, so we're talking about squared units as well. Then we can do B. So for B then, we've got this same length here. So we're looking for ones that are parallel, so that's 8. So this is 8 long. And we need this width here. Again, we look for a value that's parallel. So this one is 2 centimetres. So this one must be 2. So we'll do 8 times 2, which is 16 centimetres squared. Finally, for C then, we can see here we've got a width of 2 and we need this length here. So again, we look for one that's been labelled that's parallel, 5 centimetres. So it's 5 centimetres high. So 2 times 5, which is 10 centimetres squared. So to find the surface area, remember we need 2 of each of these values because we need 6 faces. So I've got 40 plus 40, so that's the front and the back, 16 and 16, the top and the bottom, and 10 and 10, the left side and the right side. And we add those 6 faces together. That gives me 132 centimetres squared for the surface area of my cuboid. Okay, we're going to do a couple of examples. It would be a good idea to write these down as you go. So for our first one then, we can see we've got a 3 centimetre height by 9 centimetres by 2 centimetres. It's a cuboid, so we're going to need 6 faces again, but the front, back, top, bottom are the same. So let's start with the front and the back then. The front and the back are 3 times 9, so 27 centimetres squared. There we are. The sides then are 3 high by 2 wide, so 3 times 2 is 6 centimetres squared. So there's 2 of those. And then the top and the bottom are 2 by 9, which is 18 centimetres squared. So remember, we've got to add 2 of each of those together. So we've got 2 18s, 2 27s and 2 6s, which comes to 102 centimetres squared. Now you might be tempted to just multiply these by 2 and add them. I prefer to add them separately because then I can see that I have 6 values, so I don't get myself confused with how many faces I've found. Okay, but that is up to you. I just like to make sure at the end, yeah, it's a 6-sided shape. I have 6 numbers to add together. So this one here then, we can see it's 4 by 4 by 4, so it's a cube. Remember, a cube is a special type of cuboid, so we can follow the same rules. So the front and back, 4 times 4 is 16 meters squared. Sorry, I need to change those units there. There we go, so that's meters squared, sorry. The sides are also 4 times 4, so 16 meters squared. The top and the bottom, 4 times 4, 16 meters squared. And so my surface area, 16 plus 16 plus 16 plus 16 plus 16 plus 16. Again, you might feel that you can do 6 times 16. That's up to you. I like to make sure I've got my 6 faces all together. And that comes to 96 meters squared this time. Make sure you're happy with those examples before you move on to your practice. Okay, so we've got 3 different cuboids there to find the surface area of. Pause the video, have a go at those in your maths book. Okay, so let's have a look at those solutions. So I've just used a bit of shorthand here, so FB just stands for front and back. Okay, so the front and the back are 6 times 4, which is 24 centimeters squared. The sides, 4 times 2 is 8 centimeters squared. And the top and the bottom, 2 times 6, 12 centimeters squared. So we've got the front and the back, the left side and the right side, the top and the bottom, which all add up to 88 centimeters squared. For our second one then, the front and the back come to 10 centimeters squared, 2 times 5. The sides are 5 times 2, so 5 long by 2 high, which is 10 centimeters squared. And the top and bottom are 5 by 5 this time, which is 25 centimeters squared. So again, we've got the front, the back, the left side, the right side, the top and the bottom all added together comes to 90 centimeters squared. Last one then. So again, we'll do the front and the back first. That's 9 times 3 is 27 centimeters squared. The sides are 4 by 3, which is 12 centimeters squared. And the top and the bottom are 9 by 4, 36 centimeters squared. We add all of those together, so 2 of each, I get 150 centimeters squared. Make sure you've marked your work and your working out is nice and clear for those. Okay, so now we're moving on then to the surface area of a prism. So remember the description of a prism. Okay, a prism has the same shape running throughout it. So you can see we've got a triangle at the front here, and at the back it has that same triangle. And if I cut slices through it at any point and looked at the end, I would have that exact same triangle. So it's not getting narrower as it goes along or getting wider, it's staying the same all the way through. So all of these lines are parallel to each other as we go through. So in this case, we've got a triangular prism. We could have lots of other prisms. We're going to have a look at some more a bit later. Okay. So with these prisms, I always like to find the area of the shaped face first. But again, it's up to you which order. But I like to do the ones that are a shape because they tend to be a little bit more tricky. So we need to use the appropriate formula for the shape that we're dealing with. So here we've got a triangle. So we're going to find the area of the triangles first. So remember the formula for area of a triangle is half times the base times the height. So that's a half times 3 times the height. Now remember the height is the perpendicular height to the base. So the height here is 2. It's not the 5 down the side here. It's not the diagonals. It's got to be perpendicular 90 degrees to the base. So 3 times 2 is 6. Half of 6 is 3. You could be using the formula base times height divided by 2. Again, that is up to you. So they are 3 centimeters each. So remember there's one at the front and one at the back. Okay, now we need to do the sloped side. So that's these sides here. So we've got the left side, which is this one at the back over here. And we can see it's a rectangle and it is 6. And that's why we need this diagonal number. So it is 6 by 5. Okay, so 6 times 5 is 30 centimeters squared. Now we're going to do the right side. So the right side is also 6 by 5, so 30 centimeters squared. And then we need to do the base down here at the bottom, and we can see this one's 3 and it goes along by 6. So 6 times 3 is 18 centimeters squared. Now something to take note of is that with any prism, you have your two shapes that are identical at each end. Every other side is always a rectangle. Okay, so that's what's making it a prism, is that we've got our two shape faces and every other side will always be a rectangle. So we're using the rectangle formula for all of those other sides as you find them. Now our triangular prism has 5 sides, so I should have 5 numbers to add together. So we've got 2 triangles which were 3 each, so 3 plus 3 plus our 30 for our left, 30 for the right, and 18 for the base comes to 84 centimeters squared. So again, I always like to have the right number of numbers to add at the end that match up to the number of sides. So hopefully I won't have too many or too few in my answer. Make sure you're happy with that. Perhaps make a note of that example before you have a go yourselves. Okay, so 2 for you to have a go at now then, both are triangular prisms. So pause the video, see if you can find the surface area. Okay, so let's have a look at the first one then. So starting with the front and the back. So the front and the back are both triangles, so half the base times the height. Okay, there's our base, there's our perpendicular height, and we get 20 centimeters squared for each of those. Our left side, we have got 8 by 7, so it's 8 down here by 7 going back that way, it's 56 centimeters squared. The right side is this sloping one here, so that's 7 by 9, which is 63 centimeters squared. And then we've got our base at the bottom, which is 7 by 5, 35 centimeters squared. I'm going to add all of those together, so remembering I need a front and a back here, so 2 of those, and then my left, my right, and my base comes to 194 centimeters squared. So you'll also notice, apart from the 2 triangles, all of the others have one number in common. They will always have this depth the same on each one. Okay, our second example then, so another triangular prism. So I've got my base and my perpendicular height this time, remember at 90 degrees to my base. So my front and back are half times the base times the height, which is 48 centimeters squared. I've got my left side, so over here, which is 10 times 18, 180 centimeters squared. My right side is also 10 by 18, 180 centimeters squared. And then the base, which is 12 by 18, 216 centimeters squared. Add the 5 values together, so 2 triangles, left, right, and base, comes to 672 centimeters squared. Make sure you've marked your work and you're happy with all those values before you move on. Okay, we're now moving on to volume then. So the volume is the amount of space a shape takes up. So as if it's a solid shape, or if you're filling something up. So quite a lot of the time they'll talk about things like filling a tank full of water or filling a box full of sand. So it's the amount of space that is taken up by the entire shape. Now to find the volume of a cuboid, we can do the length times the width times the height. It's the area of the base, which is the length times the width, and we multiply that by the height. Okay, so length times width times height, or sometimes you'll see it as length times width times depth, depending which way round, but it's all 3 different directions multiplied together that give us the volume of a cuboid. A couple of examples then. So our length times our width times our height. So as long as we've got 3 different directions, we multiply them together. I get 72 centimeters squared. For this one, 5 times 2 times 6 gives us 60 centimeters squared. I'm so sorry, that's not quite right. Sorry about that, we had the wrong units there. They are centimeters cubed. So remember, for volume, it is cubed. So area is units squared. We've got 3 different dimensions here. So our units are cubed at the end. So do make sure you put the right units in those as well. Okay, there are some there for you to have a go at then. So pause the video, have a go at those now. All right, so let's have a check through the solutions then. So the first one, 5 times 4 times 3 is 60 centimetres cubed. For the second one, we've got 5 times 7 times 3, which is 105 centimetres cubed. For number 3, 6 times 5 times 10 is 300 centimetres cubed. And our last one, 2 times 11 times 3 is 66 centimetres cubed. So you'll notice it doesn't matter which order I do them, whether I do the length, then the height, then the width, or whichever way round. Remember, for multiplying, as long as we're doing the same to all numbers, it doesn't matter which order they appear in. Okay, so now that we've had a look at the volume of cuboids, we're going to have a look at some prisms. Okay, so the volume of a prism is the area of the cross section times the length. So capital A for area times length. So for example, if I were told that the area of this pentagon is 12 centimeters squared and that it is 7 centimeters long, so the depth here is 7 centimeters, then to find the area I would do 12 times the length of 7. So we can imagine this area of 12 is every slice, every centimeter through here has the same. So we do 12 times 7 and it would have a volume of 84 centimetres cubed. Okay, let's have a look at 2 more examples then. So that one we were told the area and we just need to multiply by the length. Now this time we're going to have to find the area of the cross section first because we don't know the area of this purple triangle. So remember, to find the area of a triangle, it's a half the base times the height. So the area of the triangle is half times 5 times the perpendicular height, which is 8, which gave us 20 centimetres squared. To find the volume, we take the area value and we times it by the length. So 20 centimetres squared times 14, which gives me 280 centimetres cubed. So if we're told the area, multiply it by its length. If we're not told the area, we find the area first using the appropriate formula and then multiply by the length. Let's try this one then. So this time we've got a trapezium prism. So we start by finding the area of the trapezium shape. So that's a half times A plus B, the parallel sides added together, which are 5 plus 7, times its perpendicular height of 4. That gives us 24 centimetres squared. To find the volume, we take the area of our cross section and times it by its length. So 24 times 6 is 144 centimetres cubed. Make sure you've copied those examples down, you're happy with those before you move on. Okay, so for this first one then, you need to work out the volume. Sorry about that. Okay, so have a go at finding the volume of those. So you've been given the area of the cross section. You just need to multiply area and length to find the volume of those prisms. Pause the video, have a go now. Okay, so let's go through these then. So the first one then, we've got 15 times 8, which is 120 centimetres cubed. For the second one, we've got 11 times 11, which is 121 centimetres cubed. C is 19 times 9, which is 171 metres cubed. D, 26 times 7, 182 metres cubed. For E, we've got 25 times 6, which is 150 millimetres cubed. And finally, 31 times 14, which is 434, and that should say centimetres cubed there. Okay, make sure you're happy with those. We're now going to have a go at the ones where you need to find the area yourself. So for each of these, you first start off by finding the cross-sectional area of the coloured shape and then multiply it by the length to get those ones. Pause the video, have a go now. All right, let's talk through the solutions to these. And so for the first one, we need to find the area of the rectangle first and then multiply by the length, or we can do all three at the same time because they're all multiplying this time. So 6 times 8 times 11 is 528 centimetres cubed. For B, again, the area of the front there, 5 times 4 is 20, and we're going to multiply that by 8. So 4 times 5 times 8 gives us 160 metres cubed. For C, we've got a parallelogram. The area of a parallelogram is the base times the height. So we're going to do the base times the height to get the area and then multiply that by its length. So 8 times 7 times 12 is 672 centimetres cubed. Again, another parallelogram. So base times height for the area, 9 times 6, and multiply that by 14. So again, we can do it all in one go. So 6 times 9 times 14 is 756 millimetres cubed. Now we've got our trapezium. So remember our formula is a half times the parallel sides added together, which are 5 and 8, multiplied by the height. And once we have that area, we're going to then multiply that by our length of 10. So we've got our half times our A plus our B times its height. And then all of that is then multiplied by 10. So again, you can find the answers to the area first if you want to, and then multiply them, or just do it all in one go. And we get 520 millimetres cubed. Another trapezium then, so a half times, we're going to do the 7 plus the 11 times a height of 10. And then once we have that area, we can multiply that by 14. So again, you can work them out separately or in one go. And that will give us 1,260 centimetres cubed. Okay, finally for today then, we're going to look at our challenge questions. So as always, you can pause the video now, have a go at the challenge questions yourselves and then watch the answers, or you can work through them with me. So for our first one then, we're told each prism has a volume of 720 centimetres cubed, and we want to find the values of A and B. So for our first one then, we know area times length must equal 720. Okay, so we've got to do the opposite. So we take our 720 and we divide it by 48, and that will tell us the length of A. So just reversing the process will do the opposite for us. So A is 15 centimetres. For B, we know that a half times the base times the height. So a half times 12, which is 6, and 6 times B will give us the area, and times that by 15 to get 720. So again, we have to reverse that process. So if we start with the 720, instead of multiplying by 15, we can divide by 15. And instead of multiplying by half the base, which is 6, we can divide by 6. So we get 720, we divide it by 15, that takes us back to the area. We divide that by 12 times 2, which is the half of the base there, and we get 8 centimetres. Okay, so there are a few different ways you might have written this out. All right, so just be aware of how you're writing out yours. This side then, we're going to find the ratio of the volume of the triangular prism to the volume of the parallelogram prism. Give your answer in its simplest form. So first then we've got to find the volume of each of those prisms. Now, our triangular prism is going to cause us a bit of a problem because we know the base, but we don't know the height. So we're going to have to use some other skills that we have to find the height. Now, if I were to draw a line straight down the center here, I would create 2 right-angled triangles. And to find a third side in a right-angled triangle, I would use Pythagoras' theorem. So I know the diagonal side is 13, the longest side. If I had that line down the middle, it would go halfway. So I would know that this side is 5, and I can use that to find the other one there. So to find the height of the triangle, I do the longest side squared minus the short side squared and square root it. That gives me 12. So the height of my triangle is 12. Now I can find the volume. So a half times the base times the height gives me the area of the triangle, times 20 gives me the volume of my triangular prism, which is 1,200 centimeters cubed. I now need to find the volume of the parallelogram prism. So base times height for the parallelogram times the length to give it volume. So 6 times 6 times 15 is 540 centimeters cubed. So now I have the two volumes. The question said it wants the ratio of the volume of the triangular prism, so that comes first, to the parallelogram prism. So I've got 1,200 to 540. I've written them now as a ratio, and now I can simplify. So remember, to simplify, we need to divide both sides by the same amount, and we can do that as many times as we like until we get to the simplest answer. So for instance, they both have a 0 at the end, so I could divide by 10 to get 120 and 54. 120 and 54 are both divisible by 2, so I could divide that by 2, which will give me 60 and 27. And then we can divide that by 3, giving us 20 to 9. Okay, so we're dealing with ratios, remember, dividing both sides by the same number until we get to numbers where we can't divide any further. So that's quite a challenging question there to finish off with. Okay, thank you for working through that today then. Next lesson, we're going to be moving on to look at circles.